Okay. Hide this.
Not on video, but are you trying to get through?
All right.
Oh, no, you're good. I'm not close. Yes, I'm seeing shows out.
Nice. All right. I think we'll get started. Hey, everyone. Thank you for making it. Welcome to BIOS 417. It is week 8. Everyone's really busy, so appreciate making it out. My name is Eric. I am finishing my master's in biomedical data science. And so EHRs have kind of been my soapbox. My first job was at Epic. I worked at an EHR startup called Campus Medical, and I co-founder dated for like a year and a half, and everyone's like, why don't you do EHRs? And I just explain it over and over, and here we are. It's like, why not make it a class? So, and Michael, would you like to introduce you?
Thank you, Eric. I'm Michael. I'm a 5th-year CS PhD student. I work with Nigam Shah and Chris Ray, and research-wise have been focused on developing and evaluating foundation models for electronic health record data, and had the pleasure of working with Eric in our lab for a bit. And yeah, I'm excited to help teach this class and hopefully do a couple hands-on exercises with fine-tuning models and trying some LLM stuff.
Awesome. Yes. And that will be next week. Cool. But for today, we'll be talking about the history of electronic health records, or my biased take. But so when I co-founder dated, the big question is just like, Eric, why are EHRs a problem? I explained like, oh, well, there are all these like historical reasons, like political reasons, technology, yada, yada. And if we just fixed it, a lot of things would be better. And then people would be like, yeah, but how would I make money? And I'm like, I don't know. Well, surely like if you create something valuable, it'll make money. So I thought about that a lot. And remind me of something else. So today's class, first we'll go over logistics and then talk about the history of EHRs. But interestingly, it relates to the history of the internet, which was something that didn't make money and was a government project. And then the government tried again with EHRs, but it turned out differently, as you all know. We will talk a bit about maybe why that happened. Talk a bit about buzzword data interoperability, which is just the ability to share data between systems, and then a bit about where we're at now. Okay, so logistics. So technically we're in the room until 8:20, and but we'll try to keep these like about 50 minutes. We have a lot of interesting backgrounds, so definitely mingle among yourselves and chit chat. But yeah, and Michael and I will be around to answer questions, all that sort of stuff. For attendance, so all right, so I mean, neither of us plan to be very strict or anything, but this is only 6 classes. So if you are enrolled, please try to make it. If not, we'll try to have some assignment, and hopefully it'll make it more fun to learn, or make it more engaging. There's a class syllabus. I'll send it out via email again. And then we'll make the slides available via G Drive, hoping to make it public at some points, but I just want to put whatever on there for now. And then food survey. Thank you for those that submitted. So just let us know if you have strong opinions. All right. So as you all know, keep being respectful and kind to your peers. This is professional, but also just kind of casual. So we're here to just hang out. All right. If you want to pass, you got to participate in all the classes. If you're auditing, you're here for the ride. And yeah, we'll just make you review slides or something. Also, all questions are welcome. So, everyone, we're all clearly a lot of smart and interdisciplinary people, but we all have like different strengths in different areas where we've like never studied before. And this just mixes a lot of it. So yeah, I'm just curious, like how many people here are like school of medicine? Okay, how about the like businessy school? Okay, maybe biosciences? Engineering. All right, there you go. Well, we have a good mix. And there are more people enrolled, so feel free to yeah, bring up any questions. No, all questions are welcome. All right, so setting the scene. So, when Michael and I were first thinking about this, we were like, oh, wouldn't it be fun if we could talk about like EHRs, but like, I don't know, EHRs are kind of boring. Can we make it fun? And I was like, okay, well, Back to the Future had I found this out later. It's like the 35th anniversary or something. But I was like, huh, it'd be interesting if we could, go back and like change like all the things that happened because clearly there was a lot of investment, but a lot, not everything went right. And that's kind of what they did in Back to the Future. So roughly, okay, how many people have watched Back to the Future? One. Okay, great, great, great. Okay. So, well, I don't want to spoil too much, but the present, it starts out in the present, kind of sucks. But then, the centric friend, Doc Emmett Brown, he makes a time traveling DeLorean. They go back to the past and they meddle and they figure out why things sucked. And then they get back to the future and things got better. It's like, great. So, in the movie, they start out in the present, Biff's kind of like the bully. George McFly's the dad. Lorianne is the mom. And Marty is the son. And he hangs out with this weird, doctor. And he's like, hey, I made like a cool DeLorean and it can travel through time. And they're like, oh, let's try it. And they try it and they get stuck. But they go to the past and they see, wow, like everything kind of perpetuated itself. The bully stayed the bully, like the kind of wimpy dude stayed the wimpy dude. And, and the mom just got kind of jaded, which kind of sucks. But then they, meddle with things, go back to the future, and then the future gets better. And, deep down, the bully, he was a nice guy. He just wanted to help people. But, now they make sure they don't scam everyone. All right. So what about this class? Well, we can't go back in time. So we can't, go through a time travel with DeLorean, but we can go in order. And maybe there's a way to take the present and morph it into the future we want. So maybe to start, and bear with me, I had to find a way to fit this. So who reminds you of Biff? Who's kind of like the bully? And I was like, all right, well, maybe it's kind of like how EHRs are like how clinical AI is pitched to us, right? We have these big promises, they tell us like, oh, clearly if you invest in this, it'll make your life better. And for, we have clinicians in the room, like, as you know, that sometimes is the case, sometimes isn't, right? But you keep being told it's like, oh, clearly if you just invest in this, then it'll get better. So, but okay, who's the kind of wimpy dude in this case? Is it the government? I don't know, it's just like, all right, the government poured all this money, and back in the day, the government did amazing things, set up NASA, like set up all these programs, and I was like, man, but yeah, now it's just like, I don't know, it doesn't feel the same. Who's the mom? It's kind of like US healthcare, it's like sold this like bad promise and, just have to deal with it nobly. But wouldn't it be nice if like all these things just worked? And we can be, in this class, what's the DeLorean? Is it AI? I don't know. Probably not. But people are trying, and there are many ways to get around this. But this is just a fun analogy, maybe to kind of frame where we're at now. All right, so to start, the history of EHRs, and feel free to ask questions as they come up. Okay, so some base definitions. So I'm not a doctor, so people here are, so feel free to correct me. All right, so I'd say like medicine is like the science of like maintaining health, but I think of it more as like you're preventing an ailment or a disease. So you're trying to cure people. So someone is already sick, trying to cure that. And health might be like this more holistic understanding of like wellness. It's not just physically how you're doing. It's not just like what your labs are. It could be like, how do you feel? It's like spiritually, like, are you connected? Like, do you feel good about things? Healthcare, it's the delivery of services to hopefully promote health. And traditionally that's via medicine. Inpatient, it means you're at the hospital. It's just something serious usually. An immediate outpatient, just like anywhere else. But there are a lot of specialties, all sorts of domains that, are very academic, which makes sense. And because they're very deep topics that we are still studying and understanding more today. So it's a very interdisciplinary academic culture. All right, so when you hear the word digital, so like one way to frame it might be like, just think of like bits and bytes. So it's like something that is stored on silicon. And what is a bit? A bit is 1 or 0, and a byte is 8 bits. And why is it 8? It's like, well, as you'll see, like when people were making these standards, they just decided on like something that was convenient. So 8 just happened to be convenient for many reasons. I don't know exactly why, but there are committees that like work on this stuff. So 8 just became the de facto thing. We'll talk more about it later. Okay, and yeah, and historically, this is an interesting thing about. So many of us grew up in a time where most data feels like it's digital, but historically it's not, right? It's all like you just write it on paper. Like digital is a relatively recent thing, and the cost of digital things have just gone down a lot, as we'll see. But this is like relatively recent. All right, EHRs. So what is an EHR? So first, let's start with an EMR. So this is the electronic medical record. That's what it stands for. So historically, like people use this term all over the place, and it's reasonable. It's hard to define, but I would say, like, I think it's a software tool that healthcare organizations use for documentation. That's fundamentally what it is. It's like some sort of documenting tool, and it involves all the medical specialties. There are many submodules, so then people, like if you have 40 submodules, like for each specialty, then it's like, oh, like what are we talking about? We're talking about the EMR. It becomes this big monster abstraction. So that's why people might say the EHR, this big thing. There are different types of EMRs. There's like specialty EMRs. So like if you're a company and you just want to like focus on oncology, like Flatiron Health, then you would be considered like a specialty EMR for oncology, right? But then, there's a big buzz on like these integrated systems. Like what if we had, one system? I don't know how they pitch it now, but, and that's kind of what Epic is. It's like one system, but all that is just like, if you take all your specialty EMRs and you had a way to synchronize them, Epic has their own for like all these different specialties, which is really impressive. And they built it in-house. So that's why they're the integrated EMR, but really like people just want them to sync somehow. Okay, so I've been using EMR and EHR. What's the difference? So in theory, like EMR was supposed to just be like the medical side, so things that happen maybe within the healthcare system. And the idea with the EHR is aspirationally, we would all have our own personal health data and would glue it together, and then it would be the EHR, this upgrade from the EMR. But that upgrade never really happened because it's hard to connect these systems. Data standards, also like kind of open software culture. So everyone just skipped to using EMR, EHR, just aspirationally, right? It's just a more modern thing, whatever. And also health data is very broad. Health can mean a lot of things to everyone. And okay, the last thing is like a personal health record. So it's basically just an app for like you to manage your own data. So a patient-facing app to manage your own medical records. So interestingly, like at most places, so if a healthcare like institution sees you, I think like most places they own your data, but you are like you have the right to a copy of your data because data can be copied. So, and where would you store it? Maybe a PHR, maybe they'll email you a bunch of pieces of paper, but PHR might be the digital version of that. This is clearly important. It's like the obvious like startup idea. It's like, oh, just build a PHR and just be the sync. But it's hard for many reasons. Just engagement, making money, data security, and also like working with these like different vendors. Not necessarily from a bad place. It's not that they don't want to help patients. It's just that they're balancing the risk of sharing this random data and something bad happening. So why would they trust a random startup? Maybe one day. Okay. So this is what an EHR looks like. It's usually the first like digital touch point for most people, and that's why it's so interesting. So this is publicly found. Epic is like a controversial company, but they're considered, I'd say, like best in class in the US because they're like connected. They have their own specialty EMRs, so they just connect by default because it's one company. But if you see, like, there's a lot of stuff going on, and you're like, man, like this is kind of like all over the place, right? But so first idea is like, oh, why don't we make the UI better? But anyways, Epic's not unique in struggling with this problem. The other big company is called Cerner. So this is probably old, but if you notice it, like it looks the same, right? It's just like it's like the same idea. It's just like some page and you have a bunch of buttons and it, I might be trivializing a bit, but it's really hard to do, right? Because there's a trade-off between like, okay, I want this to be information dense, but also I don't want it to be irrelevant. But there's so many things going on, right? So Cerner is like popular, I think, more in like inpatient. Empirically, they got bought by Oracle. They say they're going to remake it with AI. Will it work? Maybe, I don't know. And then there are like a bunch of other EHR vendors. I just like picked on eClinicalWorks. So why would someone buy like random another EHR that's not Epic or Cerner? Usually because it's cheaper. Because if you think about it, this is just, I don't know, just admin documentation software. So there are a lot of other people that do it. If you see it's like similar idea, but subjectively, some like organizations might be like, oh, but they're harder to work with, or like, oh, we didn't have as good of experience, et cetera, et cetera. Okay, so why might we care about EHRs? So I'm glad all you made it here. It seems like you all care, but if this is your first time thinking about it, well, first it's kind of like the first touch point to a lot of the digital like healthcare data. So it's like it's the software, the clinicians, the IT admin staff, the like kind of people that do the registration, front desk. They're the first ones. This is where they type in. This is where they type in first. So this is the first chance to give them the opportunity of like, okay, like physical world, digital world. There are a lot of problems that come from this, like clinical burnout, clinician burnout. Not only is there a shortage, but it's like people are tired of these, Windows 90s interfaces. There are a lot of inefficiencies in healthcare. As many of you know, the common example they bring up is like a repeat test. So if you've got a lab before, it's like, why would you get it next day? And as some of you know, there's more complex reasons, but maybe if it was just digitally documented well, there wouldn't be a reason for that. Patient engagement. So a lot of care is like preventative. So maybe if you could have a way to reach them instead of mail digitally, it'd be easier to engage with people and kind of improve problems at the source. Then there's this idea of value-based care. So I don't know when it came up, but it's kind of like no one can really agree on what value means besides money. And we don't want that to be the root of our healthcare values. So people debate about that. But the idea is like, well, if it's not money, maybe it's data. So if we can agree on like, oh, we all care about the patient and we have this medical information abstractly in the EMR, then we can link it all together. Another note, like traditionally, like EHRs are kind of like the villains of like, oh, like Epic won't let me do this, or it's like, oh, like I'm trying to do this interesting thing, and like the EHR has just been so hard to work with. But there's a lot of people behind the scenes there that they work very hard to keep these things running, and a bunch of IT staff too that need a shout out. It's a lot of work to keep this stuff running, but nevertheless, there's a clear potential and promise gap. There's this article called "Death by 1,000 Clicks," which is like a parody, or it's like a play on words from Death by 1,000 Cuts. This was published in 2019 by Fortune. I can send out a link later. But basically it was arguing just like this was actually like my probably first touch point of like thinking about EMR so like rigorously of like, wow, like, yeah, why is this such a big problem? And as you'll see, the short answer is large government investment. And then things got better, but not how we expected. So we didn't get great money, value for our money, but it worked kind of. All right. Another thing that makes it hard is like a lot of these features are pretty complex. So this is, and I just randomly pulled this off of the internet, but this is an ED track board. So I'm not a doc, but this is, I'm assuming the emergency department, where people being seen, it's, you got to deal with it quick. And this is basically like the triage screen, right? And it's like, oh, if you see like, yeah, they have a list of, patients that makes sense. They have a little pop-up on the side that makes sense. They have a summary of, what might be important. Okay, what's important? I don't know, but it's hard. And then they have a way to quickly update the note, right? But when you look at it at like a broad lens, it's just like, like this seems kind of clunky. But when you look at a narrow lens, it's like, clearly it has a lot going on. So there's still a lot of opportunity, but it's not as easy as you think. But it can definitely improve. That is correct. HR modules. So Brendan Keeler, he calls himself the health API guy. He has a really cool blog. He worked at Epic. He's maybe like 5 years before me. And he wrote a blog post called Epic Saga. So I took this from him. Shout out Brendan. So this like seems like monstrous. This is just explain like the backend infrastructure of like what Epic is, but it's really not that much. So this like big blob over here, it's just all the different specialties. So there are a lot of medical specialties, but this might be like here. There's like what orders, ASAP is emergency, Cupid is like Cupid is cardiology. So they have cute names for these. But like all these UIs just basically look like some variant of this, right? But like the workflow is specific to the medical specialty. And a lot of work went into making sure that, like this is like how cardiologists they look. So we'll mimic that in the software. But it's basically like the same UI, but they just like built it over a long time. Okay, so this bottom section is just like the databases. And there's really like one main database. It's called Chronicles, which is on the bottom. It's a NoSQL database, but they also basically have an analytics database. So for your production data, you would have it in Chronicles. But if you want to like query data, they export it every night into a separate database called Clarity. And that is stored in like a table-based format called OMOP. So it's easier to do analytical things. And because data is digital, you can just copy it pretty easily. Then there's this whole branch on the side, and this is just like modules for data sharing. They go through this little thing called interconnect, but it's really just like all these are just like some flavor of like how do we share the data from the production database Chronicles to different parties, either it be through patients, through MyChart or these different apps, or to other organizations via like these like interconnect things. And then aspirationally, there are these things where it's like, oh, maybe we can have like a more modular community where people put their own packages and stuff. And that kind of happens, but not really. So it's still early. Okay, so there are also specialty EMRs. So the idea with a specialty EMR is like, instead of trying to win everything, which is a lot, you just try to win one specialty. It's like, if I know the most about oncology, like Flatiron Health, like they focus just on oncology, but they also went more vertically. Like they focus on the research side, where they could do like clinical trials, whatever. They had a bunch of like, they labeled a bunch of data and they used their EMR to augment that. But they're like, okay, we are focusing on oncology. That is one strategy. And there are a lot of these newer EMRs, they're more like general practice because that's easiest to get into. And then I put Athena because it's like name. I don't know if they do inpatient, but they do a lot of things. But if you look too, they all kind of look the same. But one might be nicer, one might be the other. Um, but there's this like new idea of like a platform play. So instead of like trying to win one specialty, the goal would be you're trying to be like the database basically. And like the EMR is a way to like get about that, or you try to like offer a more broader ways to reach people, and then leverage that as your competitive advantage. So one of the earlier ones is called Dr. Chrono. They just had like their EMR, but just on an iPad. So it's like, oh, how cool it is, right? And this is pretty early, actually. I think this was like, I don't know, like 2008 or something. So it was like, yeah, like great. Like, iPads were becoming a thing. So like they jumped on that. Is it better? I think for some things. So it was more lightweight. I worked at Canvas Medical. I really liked what they started as. They started as like, oh, can we focus on like this clinical charting interface? So instead of like checkboxes where you click, you would like type and you say in the note and populate these things. So they still do that, but the company kind of focused more on like, oh, can we be a platform play for other, health tech startups? Because I guess that makes more money. And you need to, right? So I don't know where they're at now, but it seems similar. And there's a very recent company called MedPlum. I'm actually very high on them. So what they're trying to do is they're trying to be like this headless EMR. So they're basically just trying to be only the database. So, but the idea is like only the database will do it well. And then you can build whatever front end on top. And then if the community wants to build front ends that just work for people, you can do that too. So there's a primer. I will link that at the end. But this distinction of like headless or like this is pretty new. Like people are just making this up, which should make sense. Okay, and last, to motivate the EHR more, is a key source of medical data. Can AI save us? Well, maybe. I don't know. The methods are promising, but an AI method, and Michael will talk more about this, isn't inherently better per se. It could introduce risks. You got to move all your data. If you make a decision, like, can people trust it, right? How good is it making it? So like, will people act differently based off what happens there? And then, the big AI craze, one framework we'll talk about is like data, knowledge, intelligence. So really like traditionally, like we all want, like intelligence might be like how you act, knowledge might be like what you know, and then data is just like what's in the world, right? Very broadly. So a lot of people are enamored by AI because it's like, wow, we could take, data, what we have in the world, and we can skip, thinking really hard about how to organize the knowledge. We can just get intelligent action, right? And really under the hood, the AI is just, outsourcing the knowledge part, right? It's just learning from the data what might be knowledgeable. But traditionally, like you could just do that on your own. You could just, interpret the data on your own and develop your own worldview, knowledge, etc. But it's not inherently better, but we've seen the big hype is we've seen this like pattern of like double descent, or it's like if you feed it enough data, or it's like, wow, it keeps getting better. Usually there's a trade-off, but like it just kept getting better. So that's why everyone's so hyped about it. EHRs are often the bottleneck for data innovation. So, but wait, Eric, didn't the US government invest a ton of money into this? They did, yes. So why isn't it better? So how do we get here? So maybe first we can talk about the history of the internet, which is an interesting parallel. So first we'll start, what's a bit? So a bit is a 1 or a 0, and a byte is 8 bits in a row. So, and the reason it's using that is you can just encode, people that developed these computers needed a way to agree on like a standard of like how to organize information. And they were just like, all right, like, let's try this. Well, first, the 1 and 0, like that's a natural thing. So on a computer CPU, like you have these transistors, and these transistors are little switches. So at the very early day, you would just like have you'd have a way to encode, this 1 or 0 in like electrical charge. And then you would use the CPU and you run it through, and it would, go through these switches, and you can like apply logic, right? And then like the modern computers is just like that, but like on an insane scale. Like they like this is the Apple silicon chip. I like it a lot. And basically I don't know, they have like something like 8 billion transistors or something. They squished it all into like a single chip. That's just how it works. So you have your CPU, you have your disk, which is just like storage on disk. Or it's like basically when you download a file, you can store it there. Then you have your RAM. It's like when you open a file, it goes there. Why you need RAM? It's a lot faster. It's like maybe like, I don't know, 1,000 times faster. But then it costs more. And then when you add a programming language, that programming language is in something, well, it's not quite as interpretable as English, but it's closer than the right machine code. Something takes that, converts it to machine code, and then runs on your CPU, and it goes ones and zeros. Cool. All right. Why is this important? Well, for context, megabytes used to cost a lot of money. So to have 1 megabyte, you might, if you wanted to have a computer that ran like an 8 kilobyte program, you might need like a couple multi-million dollars, right? Which is crazy. It's just gotten so much cheaper. The phenomenon is called Moore's law, where transistors just keep getting smaller. But because of that, fortunately, it's gotten a lot cheaper for all of us. But back in the day, it would cost a ton of money. So the ARPANET was a project started, by the US government. ARPA was like the Advanced Research Projects organization or something. They were like a blue sky organization. They really focused on R&D. Funnily, there's a book that talks about this called The Wizard's State of Play. I read the first half. And basically, it's kind of funny. It started because like the Russians launched Sputnik. And then it was just like, holy shit, like the US has lost its edge. We got to prove that we know the most about science. So they started ARPA. And then, so ARPA was focused on getting the ship. So ARPA spun out into NASA. So NASA spun out into its own thing. So then I was like, okay, NASA will work on the space problem. But what are we going to do at ARPA? And they're like, well, I don't know, but we should keep it. So they repurposed it. So they're like, okay, we'll just be this blue sky organization for R&D projects. And it's almost entirely R&D focused. So the practical problem they had was like, well, this was, in the 60s, like computers were new and we had these research institutions and almost like, funny, man, almost like bio research today, people are repeating the same experiments over and over because it's like, yeah, the equipment's just hard to move and it's hard to redo this stuff. So the computer people were like, hey, what if we had a way to share that and port that over a network? So they started the ARPANET project. It had 4 nodes. The first transmission was UCLA to here, to Stanford Research Lab. And they created this abstraction called an interface message processor. More reading on that if you're interested. It was kind of cool. It was like, yeah, it started, like 1969. And then it later expanded and slowly through this like government invested, very open-ended, they created this network where they could share information and like democratize it and make it cool and available as a service. This is a timeline. There's a guy named JCR Licklider, and he was like, yeah, he just had the craziest ideas. Like he talked about AI like in the 60s. And I was like, wow, like, so he pitched this thing as an intergalactic computer network. And then he left. So like, someone else like took over at ARPA and they're like, well, maybe we should look into this. So they started the ARPANET project, worked out a couple of years. And the thing that's taken for granted, like the idea of like sending packets was like not intuitive. It was still like early research, but they're just like, whatever, we'll try it out and see how it goes. So a lot of work went into that. Different standards. One, you started to standardize it more. And then now everyone codes in JavaScript. Okay, so what is an internet or like a data standard or internet standard? So it was basically just a common language of like, okay, we know what we want to do. We want to take these like bits and bytes and like send them to each other, right? But how can we agree how they're organized? So we've agreed to like structurally how they should be, but how can we agree like, like which part corresponds to what? So that's what these standards come from. Like there's still standards today, like people have like working group meetings and have requests for proposals. But high level, there are standards that might talk about like, okay, if you take these packets of bits and bytes, like how should you send it? And what information should you include when you send it so it goes to the right place? And then also like once you unpack it, like, okay, how should someone interpret that? So that might be a data standard. Yeah, so like the digital standards, they're so successful today. A lot of kind of unsung work goes into it. And it's really cool. Yeah. And like, yeah, it's crazy. It's like there are standards for like how we should number like the IPs on our computer. Like there's a lot that just goes under the hood. So definitely something to appreciate. A lot of it too is like publicly funded, kind of like research that happens today. Okay, so given that context, so what about EHRs? So preface too, and say this again, like EHRs aren't inherently bad. A lot of work goes into it too. There are like committees, there are like different standards, like working groups. There's a lot of technical work with ambiguous boundaries and like a lot of things needed to account for. And it's kind of similar to the internet, right? And like, so the government invested a lot of money and they're like, okay, the analogy was like, we can create this like medical information highway, kind of like the internet was like a government funded information highway. But what's different? Well, like, I don't know about like subjectively, like the vibe of EHRs is much more political and it's more like gatekeepy of like, oh, but how do you know? Or just like, oh, like, how can I trust you? Which makes sense, right? You want to be trust, but yeah, that just scares away a lot of developers. So then it's like, oh, people don't really want to do that. Interestingly, even though they're both like kind of government sponsored, the internet was very much research first, and it focused on like the specific user problem, which was how do we share these compute resources across this large land? Now it's interesting. EHRs, it kind of feels like regulation first, where like these vendors cater towards like the government requirements, which are very important. But then a lot of the innovation has been on business, like distribution, like how do you like capture a lot of the market and create dominance there, which again is innovation too. It's just different. All right, so for health records, historically, why do we need EHRs? Like, well, paper records, like the motivation was like, yeah, you go to your doc and like, if you have one doc for your entire life, that's great. But what if you move, right? And it's like, how do they find these paper? They sift through like, maybe this is wasting time. Maybe they had the fax, but people still fax, so whatever. And then also handwriting, right? So like doctor handwriting legibility, that was a big complaint. So, and this was around the dot-com boom, right? That was like 2000s, and they're like, whoa, clearly like digital's working. So why can't we have digital things? Right. So maybe as a side first, so health record data, like, and this is still true, it's often very sparse. So like what sparse means is like, it's like sparse in general is just like means like spread out. In this context, it means like there are many like different possible things that could come up, but for maybe a single instance, not all those things could come up. Like for example, like, oh, like I'm not going, let's say like I broke my leg or something, right? That's like one of like 10,000 things that could happen to me. And it's not like where, I don't know, I might be like, yeah, like basically a lot of possibilities. And when you think about it, it's like, okay, why wouldn't you always use dense data? Well, there's a trade-off. If you're always dense, then you need to have like a space reserved for every possibility. So if you have a lot of possibilities, then like computationally, it might not make sense. So the context here is like, there's a data standard called Odyssey OMOP, which is used a lot for analytical purposes. And it defines like a tabular base. So it's good for dense cases where you have you want consistency of the data and the data is like, will be stuck together. But that's not always the case when you're like transmitting between like different, like when you're operating in healthcare and like your EMR is talking to this other system, or like you're on your phone, it's going to this other system. So there's a need for sparse data models because it's like, okay, what if we want to send short messages that just say one thing? We don't need to include everything. We don't need to slow everything down. So there's a standard now called FHIR. And basically like the thing that makes it sparse is like most of these fields can be optional. So it's like, you could say like, I could like not include the bottom half of this message and it would still be a valid FHIR message. So that's what makes it sparse. Okay, so health records, humble beginnings. So there's a programming language called MOMPS, which is still used. It's kind of crazy, but it's developed at MassGen. It's pretty niche, but the thing that made it good, it was the first programming language that was good with sparse data models. There's no SQL data model. So it fit healthcare data as well. There's a system that still exists called InterSystems. They developed a database called Cache. So M works really close with the database. Cache is a database, so they just kind of work together. And yeah, a lot of Epic's code base is still in mumps. I mean, and it works, like they QA really well. However, that just makes it harder to do like cooler, newer things, but they still get a lot done. There's like a project called like Hyperspace or something. Not Hyperspace, it's like, I forgot, but like Hyperspace is the current thing, and they have like some new one they wrote in C#. What would be better? I don't know. All right. So all these problems, so healthcare data is sparse, but we don't want these filing records. So the government steps in and says like, hey, like, oh, maybe we could like fix this or make it better. So the government's been thinking about this for a while. So HIPAA, which we've probably all heard of, the healthcare privacy law, it's actually about health insurance. It was in 1996, and it did things like COBRA and like making sure like, oh, if you're, I don't know, like if your spouse leaves you, then you'll be okay. Or if your employer like screws you over, like you'll have an option for health insurance. And they added an addendum in 1999 about health data, because they're just like, oh, what if in the context of this, like what if like a health insurer tried to use my data against me? So then they thought about it and they're like, okay, HIPAA, like that makes sense. Okay, so health records is a bipartisan issue. So it started with George W. and he had this 10-year plan for IIT. So he created this office in the government, which still exists. It's called the Office of the National Coordinator of Health IT, which is called ONC. And it drives a lot of the regulation. And then in around 2009, Barack Obama leads the Affordable Care Act. And as part of that, it has an idea of like, okay, can we convert in an effort to make things more efficient, all of these paper records into digital records? So the Centers of Medicare, Medicaid, they really want to create this medical information highway, similar to how the internet was an information highway, fix these usability issues for the end users and go from there. So the idea was, okay, if you want to get reimbursed, then you need EMR that is approved by the government, and you need to prove that you are using it as part of this effort to digitize this information. Okay, so Epic. So this is a picture of Judy Faulkner back in the day. She would show this at staff meetings. So she started in 1979, a company called Human Services Computing. And she still is like really passionate about computing and medicine, Yes. Oh, yes.
Yeah, so I'm under the impression that for a lot of interoperability efforts, people use like the OMOP common data model. If FHIR is like better equipped, given that it's better with like sparse data models, is there like a shift to use FHIR over OMOP or?
Yes, that's a good question. So the question is like, why not pick one data standard like OMOP or like, is there a better one? We'll talk about that later. The short answer is like, it's just like, if you're doing something real time, FHIR might be easier to work with. But if you're doing like large population things, like big analytic things, OMOP's probably easier to work with. So it depends who you ask.
Yeah, actually, we did try to do that earlier this year.
Yeah.
It just kind of fell through. It was just the data standards were just so different, and yeah, it was just really hard to like reconcile them, unfortunately.
Yeah. All right. And we'll talk a bit about that. I'll try to squeeze it in. Okay, so basically Judy Faulkner starts this company, and a couple of things she does really, really well. She keeps the company values driven. So she really focuses on, like, she grew up in Wisconsin, really focused on, all right, let's keep it local to the community. Let's bring the good things here. They're privately owned. They're still privately owned. So no acquisitions. They just build everything in-house, and they really prioritize reliability. She had this insight to use, so Judy was a programmer. She had this insight to use like the programming model that fit sparse data, which was M, over SQL, which was popular at the time. This was the 80s, so very early. And then she just like slowly built the company. So the government mandate happened 30 years later. So it's like, yeah, she built this company for 30 years. And then it takes this bell curve effect because they've been reliable for so long. And why might other health vendors be unreliable? As you all know, it's hard to sell into healthcare. So then you overpitch and then you under deliver. But yeah, they just didn't do that. They just took it slow and did a great job. Yeah, they've had 0 acquisitions, which is crazy. So a lot of other companies try to acquire, like the bits and pieces, like, oh, why don't I just like get a huge fund and acquire 20 specialty EMRs? It's because like maybe they all have different code bases, like different people wrote them. There's different thinking that goes into it. So they have to be integrated. Yeah, there might be a way to glue it together, but you still need to think deeply about it. Won't be automatic. So there is a way, but it is very hard. Okay, so how do people acquire an EMR? So what's the install process? So maybe this might be a fun question. For people in the audience, how do you think something physical becomes digital?
Yeah.
Yes, OCR, good. Which is like one way. It's like you have a program that like scans an image and then it can detect that. Yes. Yes, good. Anything else? Okay, I think you're both right. And I think the root of it is like, whoa, someone does it manually. Yes, either they type it in or they take the image. It's not magic, okay? Someone has to do it, right? Because how are you going to represent something physical as bits and bytes? There's always a step in there that someone has to do manually. So an EHR install, it might take a while, like 1 to 2 years, maybe a couple $1 million for a large health system. Like, why is it so big, right? It's because they need to figure out, okay, so for whatever their old system is, how do we take all the processes, workflows, and make sure like they still exist, or we're doing the same things, or people have the same expectations. So the healthcare workers, they just keep doing what they do, right? And they're just told it in advance, okay, strategically we will move to Epic or Cerner or eClinicalWorks in 2 years, right? But just know that's coming up. Then they find a way to digitize all of that, and whatever they can't port, through scripting, they just do it manually. They just hire a consultant, and they have a bunch of meetings to make sure it's right, which is important. And yeah, they just have armies of people that just like type this in, and it's hard. And I had to do it when I was at Epic. So, and it's not trivial either, but there might be ways to do it better. And then you got to figure out how to integrate all your current things. And then there's the magic go live. It's like the week where you actually do the switch, and then a bunch of people are on staff, do shifts just to be there just in case. Now, and this is another thing. So I'll add this. So many people like blame the EHR or the vendor for like, oh, like they won't give us their data or they won't let us do this. But actually, most health systems technically own the data, and the EHR is just like the way to access it. So it's not like the EHR vendor owns the data. They're just like kind of the gatekeepers. But technically, the health system owns the data. So if you can convince, the health system leadership, like, yeah, they like, and the reason the EHRs are so stingy is like they are at the service of the health system. So, and the health system, needs to have good reasons. So there are other ways to think about that. Also, there's like, after you install an EHR, you have a lot of IT to maintain things, update things, yada, yada. So maybe you could talk to them too, because I think a lot of them are bored. Okay, international. So someone asked about international. I don't know that much, but subjectively, like, yeah, I think the US is just a couple years ahead because they just spent so much more money. Some places are just trying to do the same thing. Some governments are trying something new. Apparently Estonia has like a blockchain, thing. I don't know how, it seems interesting. But it's owned by the government, so it's not like completely amok. And then, and yeah, everyone has their own regulations. So because a lot of these workflows are tied to like, oh, like what does your government need or require? It's usually linked to that. Okay, so data interoperability. So this is a buzzword that comes up, maybe like a base definition. Interoperability is the ability to exchange information across systems. So in this context, we'll say like interoperability means like organizations. So from Stanford Healthcare to like Sutter Health, you're two separate organizations and you want to be interoperable with those organizations because maybe a patient goes to both, right? What about within Stanford? So like if Stanford has thousands of random apps, how do those glue together? So I'll call that integration. People might just say interoperability because like it's the same idea, but we'll just add that distinction because it's a separate problem. And finally, there are data standards. So just again, people like get into committees and they agree upon how do we organize this information. So one many you might probably worked with is a comma separated value or CSV. There's also tab separated values. There's like JSON, XML, etc. And these all have their own use cases, just kind of like, different little languages. So maybe a motivated analogy. So all of us, yes, this is the USB, like all of us have USB devices. So wouldn't it be great if we just had one kind of USB that just worked everywhere? And the answer is yes, it would be great. So yeah, everyone tried and it's like, okay, why don't we just do USB-C? We'll just ship this and everything will be nice and easy. But then the USB-C came out, which it needs to. And then we got to buy all these adapters. And it's like, okay, well, how do I get all my old things to work? And yeah, that's a traditional problem. So like interoperability, I think it's kind of like language in that, it might be more efficient to have just a single language, but as long as everyone agrees and there are reasons languages exist, and you got to respect that. And also, yes, the USB-C, like they do different things because now you've consolidated, these ports might have done separate things before and like, okay, we want to just automatically work. Well, a lot of work goes into that. But it's in an ideal world, it'd be nice because it does have a lot of good effects. All right, so data standards are kind of like little languages. So again, it's just a way of how data should be formatted. One thing like language, it needs to be very flexible. So it's like, okay, you might be more efficient if you only think about one party, but then you just like won't be inclusive enough to work for everyone. So that's the balance you make. So important thing for data standards. So this data standard is about the structure. It's not about the information. So the same information can be represented by two different standards. Kind of like you might say one thing in one language and then like the same thing in another language, right? And it's like the information is the same, but the modality is different. So good standards just accommodate for that. They have organizing bodies. A lot of people work on this. So one of the big ones called HL7. They're the ones that make this FHIR standard. And then Odyssey makes the OMOP common data model. There are clearly more. Those are just the ones I've had to work with. Okay, so healthcare data standards have evolved as kind of the networking capabilities and different things evolve. So HL7v2, I'll show pictures later. It's like, it's just like blobs of text that are like delimited with pipes. And it's used just this lowest level protocol. a lot of places still use this internally. So if you want to meet people where they're at, like, yeah, maybe you ask them about their HL7v2 feeds. But then the government was like, oh man, like, and this is HL7v2. It's like, oh man, like HL7v2, like, yeah, this is efficient, it's compact, but like, isn't it hard to read? It's like, how do I know like what this, like, what's pad ID 1, 2, 3, 4, right? Maybe I could guess, but like, wouldn't it be great to have something that was human readable? So then they came up with HL7v3, which is, I guess it's human readable. It's a lot, right? But technically, if you could say like, oh, like here, there's like, the top is ID root equals blah, blah, blah. It has English words for like all the different concepts. So it is human readable in the sense, like, yes, if someone sat down and really thought about it, they would have the information to do this. But the trade-off was it took up a lot of space, just like, yeah, it's a lot of text to represent small things. So then HL7 FHIR is what they hope to be the one standard that wins, and it uses what the modern web uses, just like JSON and REST. All right, more healthcare data standards. There's OMOP, as it was mentioned, is like more table-based. There's something called ANSI X12, which not like it's basically like HL7v2, but they use stars, and there are like other things too, like looping segments, but I don't think anyone likes it. But they just use it in like billing world, I guess, in other places. And there's something that might come up, there's like CCDA or CCDs. So it's continuity care document and consolidated clinical document architecture. All right, and the reason these exist is like, along as the ONC was operating, very well intended. They're like, oh, like could we have like more portable ways to transmit this data? So CCDA came up. It's just a type of XML, and XML is just like something in the middle. Like so it's just a type of that where it's like you have to structure it like that, and you have to have these additional requirements. But that's something that a lot of people use. So one thing that people might have heard, there's like Epic has Care Everywhere. The way Care Everywhere works is it takes the things in the Epic database and serializes it into CCD documents. Cool. I'll try to blitz through this. There are more data standards that solve other problems, not just about exchanging data. So there are standards involved in like, how do you authenticate people? One of them is called Smart on FHIR. So it uses OAuth 2, and OAuth 2 basically solves the problem on the left of like, okay, wouldn't it be great if I just had one account that I could use to log into many places? So the login with Google, OAuth 2 is the standard for that across the broader tech industry. Smart on FHIR is like that, but applied to FHIR data. Like, wouldn't it be great if I just used my EHR account to authenticate for these random apps? So it's similar, not exactly the same, but use the same ideas. And then there are like earlier standards. There's one called CDS hooks, which is like, okay, if I invest all this money and like do this research to make a clinical decision support tool, how can I plug that into production without, forcing everyone to install it from source or whatever? So this is a framework to like, okay, so you send these small targeted packets, you run this, service somewhere else, and then you send it back. And this is the standard for doing that. It's still very early. Other ideas too, like smart health cards. So, and this is all from like one organization called Smart. They do a lot. And I think, yeah, I'm not sure anyone else does this kind of stuff. So it's very cool. And they're trying to be like one of the standard orgs. Okay, and then how do you go between, data standards? Well, that's something called data mapping. So there are many informal terms, but if you work with data, as Michael mentioned, like you might have a bunch of your data in FHIR that gets sent healthcare operationally, but how do you like convert it to OMOP or go through these things? I've been stuck working on this problem. So this is my second time in grad school. My first time was at Georgia Tech. I had to work on this problem for a summer. I came to here, I'm like, okay, I'm finally done. I can do this interesting thing. No, I still have to work on this. So the idea is basically you might have like these two different standards, and you again, this is how the data is represented. So you have the same idea. In OMOP, it's called a person. In FHIR, it's called a patient, and they have these different fields. How do you map between the two? So if all your healthcare data is like formatted on the right, how do you get to the left? So, you just like get in a bunch of meetings and you're like, okay, I think this goes there and this goes there. And, like this is missing here. So you do that analysis. Usually someone just either a bunch of meetings or do it alone. And then you write code to convert to that, right? And so that's like the data mapping problem. And it's, yeah, it's hard to, it can be like, it's a lot of work. So, and this is like what the base problem might look like. So basically you might start with, okay, let's say I have a bunch of these like objects in FHIR. And again, it's like the sparse data model. And I want to convert it to something like this table of CSVs. Well, you can represent, a single row and a CSV as like the same structure. And then you just write code to say like, hey, like, like this ID like go here, or like, this birthday is a combination of these students, right? So the code's not necessarily hard, but it's just kind of like, it's hard to keep track, hard to maintain. And again, you got to handle for all these sparse cases, right? There are a lot of got yous. Okay, so why doesn't everyone just use one standard? Which is a question that came up, a good question. Yeah, like everyone wants that if people can just agree. So it's like, why doesn't everyone use USB-C? Well, and there are a lot of reasons for that. It's like one day there will be a day where maybe everyone uses USB-C. But for now, there are reasons you keep your old one and you just keep going. And FHIR is trying to be the single data standard. But again, like Mike mentioned, it might not be great for research because again, they're like research, you want to constrain the cases and you don't want to redo the analysis of like, oh, like what's actually in my data, right? To check for that. And then OMOP might have pre-solved that problem for you because someone else has done that conversion. All right. So yeah, so where we're at now. So right now, a lot of money got poured in through like, these ONC incentives for people to adopt EHRs and, use them. So that the term was called meaningful use. So a lot of data is digital now, but it was very painful, but it is digital. Great. Yes. And we've had these systems for keeping it digital. Yeah, a lot as a byproduct, a lot of institutions just invested heavily on whatever EHR they picked. So they could, like whatever leaders just had to double down where they're at. The government works to make new standards. It's painful in progress. And they renamed meaningful use because it got really toxic. All right, convincing everyone to share. Okay, so abstractly, everyone would love to share, but no one wants to risk or give the most. There's an essay I read in high school. It's called Tragedy of the Commons. So, and the basic idea is like there might be this shared common resource, but every individual person is incentivized to take as much as they can. And instead of doing things in a sustainable way, things just kind of whittle out and it sucks for everyone. So this might be a similar problem. It's a social problem and a technical problem, and among other things. So yeah, clear investment, a lot of efforts from ONC. Things are digital, but people are burnt out. If data is digital, it's portable, but we've got to make sure people trust it. Everyone's afraid of getting sued. And yeah, but there's a lot of interesting efforts that are going into making this better, standardized groups. And we need to find a way to, I guess, catch up the tech or make the culture better, like the internet. All right, and thank you for listening. And I will send out these slides. Yeah, any questions or comments? Yes. That's a good question. Okay, this is very empirical. So like, when I worked at when I was at Epic, like my job, I was basically like a consultant for a health system. So like I was basically doing like customer support for like, a mid-size health system in Ohio, like a mid-size health system in like Connecticut and like, like an academic health system, right? And like political is just like, people were just playing power games. So like, I think, I'm sorry, that's not a very formal definition, but I think the idea is instead of focusing on what's the problem to solve with the same intentions, there's the additional problem of people are vying for their own status in the middle of that, which is reasonable. And it's something I dealt with a lot at work, right? Because it's like, okay, there might be this bug that Joe's complaining about. And I'm like, okay, Joe, here's how you fix it. And he's like, I don't know if that's how it is. And I'm like, okay, turns out Joe really wants a promotion, right? So I'm like, okay, Joe, like, here's how you can show your boss that you fixed this, not me. And Joe's like, great, that sounds great. And I'm like, okay, great. So maybe stuff like that. Cool. Any other questions? Yes. Oh, yes, yes.
I feel like that's a huge. It's like, especially like why Epic is like it's kind of like right place, right time.
Yes, yes, yes. That is a great point. I don't know much about those specifics, but I lump that together with that was around the Affordable Care Act. So I think that was also like 2009. So I think whatever I covered around 2009 was like what I think about high tech. I think it had a lot of the meaningful use incentives. Oh, yes, yes. Thank you, Remy. Yes. Yanin, if you have a question, feel free to pop it in the chat or just bring it up.
Hi, Eric.
Hey.
Hi, Eric. This is Yan. I'm a student from the School of Medicine in Translational Research and Applied Medicine. And I have a question, which I'll also post in the chat for the group.
Yes.
What is your experiences or knowledge today regarding how states around the world manage EHR? You mentioned something regarding blockchain. The reason I brought this up is because I actually, I think 3 to 4 years ago, before the pandemic, I actually participated in a conference. It's called Back to the Future, hosted at Harvard.
Oh, nice.
And
Whoa,
yes,
I didn't
yeah,
go to
it's
that.
really
I didn't go to
interesting. They did talk about a lot of the future of EHR.
Yeah.
What's the I would say like the resistance from government and how new technology can be integrated. And at the time, blockchain was quite the under the spotlight. So there was a lot of discussion. And you mentioned something. I think there was another state. Was maybe Europe.
Yes.
Can you maybe expand on that?
Yes, of course. So like, yeah, so technically the US has already doubled down on their approach. So that's why we're kind of stuck. But if a government wants, learns from these methods and wants to do something new, they totally can. So Estonia, what they did is, so what a blockchain is, not an expert, but high level, it's like a digital ledger that is public and is immutable. So it means like not anyone can change it unless everyone agrees, and it is public so everyone can see it. So it'd be like if you have a public Google Docs spreadsheet, but to have a new row, you need to get everyone that's maintaining that spreadsheet to agree, like we should add this row. So the nice thing about the blockchain is, technically speaking, like, yes, anyone could see the transactions on there, and so it's more transparent. So what Estonia did, like a high level, is they decided, okay, we will host like the metadata involving all these health record interactions, and we'll put it on a blockchain. So anyone can audit it. Everyone has the same like ID. The actual PHI is not on the blockchain, to my knowledge, but it's just like, oh, like how does like this clinic know that they went to this other clinic, or like who has that information that might be on the blockchain? It's either that, or it's either like it's a blockchain that is shareable among the private orgs, but not the public. So it's like public among the health systems. And maybe they put PHI in there. The reason you might not want to put PHI on the blockchain is it's immutable, right? So if like something bad happens, it will be there forever, by definition. Hopefully that answers your question. And also, like, I don't know, like other countries, like they're doing their own thing. Like the ones that have installed Epic, internationally, like they're just like, oh, the US did this, so we'll try this. Is my guess.
Thank you.
All right, yes.
Let's see. Are they looking to bring like an EMR or are they that just like standardizes what should be for use in the hospital system?
Yeah, that's a good question. I think they will stay as the neutral body of, we will develop these standards, because the tricky thing is if you make your EMR and you force everyone to use it, and you're the government, then you're kind of going against like the capitalistic model of a free market. So yeah, they wouldn't do that. But a data standard isn't a product, right? It's just a way for everyone to agree. So they can say, and here's the thing too, like I have a local doc back home, and like everything he does is still on paper. I'm like, wow, like how do you do this? It's like, yeah, most of the people he sees are just like, 60-year-old like Chinese moms, and like they don't need it, right? It's just like he doesn't need it anymore, right? He doesn't need like necessarily all this like fancy government funding. So he just does it, it works. So yeah, and that's the way the government would incentivize it, is like if you want to get funded by government programs, you need to follow this. Yes.
So with the health system, they have this EMR, and then they're like external vendors that offer additional services that
Yep.
to integrate with EMR. And there's some of the health system have their own like informatics team. They're trying to develop like custom-made tools.
Yep.
So when it comes to integrating this EMR, like both of these, it doesn't matter if it's like external party or internal party, it has to meet the same standards for the integrating into EMR and have the same kind of level of access. There's some differences. If you're like developing internally, you have easier integration path than if you're trying to come externally.
Yeah. So if I could rephrase the question, so it sounds like it's like, let's say, is the question like, oh, if you're working with like these IT teams, like how much access do you really get or something? Yeah. So and you brought up a great point too, where it's like internal, like if you work within the same organization, it's still hard to organize everyone, but it's just like, okay, like we all trust each other, right? So we're under the same contract, so you just share whatever, right? It's like you can share with a coworker. But if you're working with a vendor, the reason like yeah, so the data standards are for like APIs, which are application programmer interfaces, but it's just like, it's basically like, okay, like a layer on front where the organization decides like how much they want to reveal and under what rules, right? So it's just a way to figure out. So the answer to that is, unfortunately, it's definitely going to be less than what's happening internally. Like that data might be there, and the trade-off is just like, the trade-off they're making is like, if we trust you completely and have the same liability as a coworker might, we can give you everything. But if we can't do that, then you'll need to go through this more formal route. So really, like, the answer is it depends. But if you can just make people feel safe about it, then there might be a way to go lower. Yep. Yeah.
Two guiding principles of the third party system. Guiding principles to be necessary to perform the function. Second guiding principle is every third party vendor has to sign a business associate agreement. So think about,
Yep.
there's a cyber issue which happens a lot. Who's going to get sued? So if it's internal, Stanford's going to get sued. So into some startup, the startup is going to get sued, and the general case precedent is like $1,000 per patient record. So that raises a really interesting challenge for startups where they want to ingest like all of the data to create an AI model versus like, I just need all of the authentication.
Yep.
Standard 10,000. But I think that's how Stanford runs it.
Yeah, thanks, David. Oh, no, a lot of great points. And it's like, it talks to this trade-off of like, yes, you could share everything, but you also share all the risk. And if it's hard to negotiate that. And Eamon knows a lot, so definitely talk to him too. Yes.
I think very much you don't know as much about how it looks in different places.
Mhm.
I've heard anecdotally that in the US, definitely on the end.
Yeah, yeah.
I wonder whether that is like the future. But also, I'm just curious in general to know if people have looked into sort of practicality in terms of parts of the world, types of healthcare, yeah, whether it's like your job there.
Yeah, definitely. So that's a great question. Basically, like how might the US rank in other countries in terms of like usage, like, or just using more? Could that be like government driven? Do people study this? I'm not sure if people study it. I will say like empirically, okay, like, yeah, well, or whatever, like empirically, a lot of it is government, like a lot more is government driven than you think. And that's what surprised me when I worked in the industry, where it's like, wow, like okay, so this is the craziest thing. Like when I worked at these like health IT startups, and we are like, oh, like, this new ONC law is coming out, we need to have these FHIR APIs up, yada, yada. We would scramble to develop these FHIR APIs, and spend all this time writing this code. No one would use it, or barely anyone uses it, right? But the reason they needed it was they needed to say like, oh, we are technically compliant by the government. That's the real thing they wanted. And the goal of the government is like, yes, if we have these APIs and make them accessible, then we'll create a culture like the internet where people can freely use it, which is great. But that was almost completely government driven. Yeah, it wasn't like, wow, we really focused on these interesting use cases that it was hard to share that data. They didn't focus on that. They focused on, okay, how do we force everyone to be nice? And that's kind of why we've ended up where we are. Yes, Gordon?
Given how like Epic is such a big player, and I'm under the
Yep.
impression that it's kind of a standard, outside of like care everywhere, what kind of incentive do they have to like play nice with other EHR vendors like Cerner or like Flatiron?
Yeah, no, that's a good question. So it's like, why would an EHR vendor play nice? The one is like the government. Two is like they are technically at the service of the customer, which is the health system or whatever clinician. So if the health system says like, hey, it's really bothering my patient care that you can't integrate with this EMR, then that becomes a top priority ticket. But otherwise, they have all these random features to do that. Yes.
There's been any efforts to make like any like universal environment data interoperability.
Yep.
And given that like other countries have like national health insurance, like they try to use their own universal MRI. Developing their EHR.
Yes, that's a great question. So the question is, why don't we have like universal MRNs? And an MRN is a medical record number. So it's like, why can't we like agree on like who's who and like have a standardized way to do that? Like I know some countries definitely are. I don't know which ones off the top of my head. It's kind of the same reason, like as a US citizen, you just share your SSN everywhere. It's like, why do I need to do this? It's just like, well, we don't have like a universal identifier because it'll hurt people's privacy, which like it could, right? But it's like, so unfortunately, there are a lot of company like I call them like middleman company that like focus on like patient record matching. All like, okay, I've never worked at these places, but the impression I get is like they're just like these large, they just bought a bunch of these lookup tables and they just like match, you know what I mean? It's like not fancy, and you read their websites and they're all like marketing. That's why. So there are companies that solve this problem, but it's not like they're just trying to make money. And the reason it's not solved is like that might be a broader government issue. But it's a great point. It's like, why can't we just have a single identifier? Yes.
Yeah, I just had a question. I know within Epic, there are already existing data models like Slicer Dicer.
Yes.
And you can also deploy predictive models like sepsis prediction within Epic itself.
Yes.
So can you speak to, Eric, why people who already code in Python
Yes.
and R don't use the Epic tools? They kind of embed their own tool and try to find it. Is it just easier from a usability standpoint, or is there a lack of awareness, you know?
Yeah, that's a good question. So basically,
yeah, they can do all these cool things. No one outside of UGM is aware, right? You're like, okay, that's not useful.
That's a great point. So basically, the question is, EHR vendors like Epic have a lot of existing modules for their developers to build off of. Why don't people use it? Some of them do. The short answer is like, so technically the health system owns the database, so they technically have a way to skip it, and it's just not fun to work in. And part of it is like, at least in Epic's case, like their entire code base is in M. I think I have an M snippet somewhere here. Yeah, so the code base is in M, and basically what you can do in M, you can do if, for, go to, and like that's it. And it's like, wow, it's like, how did Epic write its code? They just do like a ton of QA. They have an insane amount of QA, and they do a great job at it. But I'm just like, wow, it's kind of miserable to write in. So the intention is great. It's like, yes, let's build an open community. We'll build tools on top. What people really want is like, I really want to just like run loose on the database, right? But then there's like, privacy, which is valid, but it's like, okay, then that trade-off comes in, and right now that culture is very political. So people could use the tools, but it's just like not in a language that most people use.
So
Yep.
even things like ITB2, like again,
Yeah.
the world of like Kaggle and towards data science and like open kind of calls for that is so different than the insular world, especially of Epic.
Yes.
So I wonder like why those two don't communicate, because then you could just
Yep.
write a text wrapper to translate M code into Python.
Yeah.
But no one does that. I guess like
Yep.
financially, that's not worth it.
Yep. That's a great question. I think historically, financially, it was not worth it. Maybe generally I can do that now. I don't know. But also it's just like, man, it's like whatever I say. It's like if you're picking like class project partners, right? You know, you want someone that matches your vibe, right? So it's just like, yeah, like clearly these communities, like it's less about the communities aren't doing the right things. It's just like the vibes are just completely different. So when people have a choice, the vibes are off. Yeah. Yeah. That's an interesting point. And also like maybe more specific, there are things you can do in Python that you can't do in M. Yeah. And there are things that are easier to do in M, like it's more integrated with the database that might be harder in Python, but Python's just been more flexible. Oh, yes.
Someone told before that EHRs initially are meant to be like a billing machine.
Yep.
That's what they primarily designed for.
Yep.
Like when you were like preparing this lecture, have you come across this perspective, and can you talk more about it?
Yes. Definitely. So the question is just like, yeah, historically EMRs are just like billing. Everyone complains, it's like, oh, EMR is built for billing, and then everyone debates whether that's true. Yeah, that was the first use case. So like back in the day, you know, Judy Faulkner started this company. So so she started in 1979. So in 1979, again, computers were very expensive. So the only people actually using computers were for the really early thinkers, like these niche use cases. So, and usually the people that were doing this, like, again, this is 1979, computers weren't everywhere. One of their main problems is billing, right? It's just like, all right, like we need a logistics platform. We can't do these fancy medical things. So that's what they designed for first. So yeah, I think that's true.
I think it's because of US healthcare specifically is so much like insurance, private insurance, like focused. Well, to the question about in other countries that it's more like a government funded. So maybe
Yeah.
that's why also there was so much of the motivation to develop the EMRs in other places as it is in the US because of the structure, the financing.
Yeah, that's a great point. It's like, okay, how much does it have to do with like the government structure, how might have this culture evolved? So there's a book I read a while back. It's called American Sickness by Elizabeth Rosenthal, and she talks about like, okay, so clearly there's more to it, but I'm very biased. I think payers are kind of evil, and they're not evil in the sense that they're evil people, but it's just like, okay, they have a lot of incentives to jack these codes, and basically what happened was, again, the book has more. This is just what I remember. When people back then, a scalpel, was manufactured for $1 and it costed like $1.50. That makes sense. And then, these insurance companies, again, you need a pool liability. That makes sense. And then the insurance companies decided to get, tricky with it. They're like, oh, can I negotiate, right? Because the patient's not paying, so we can do what we want, play these games. And they had a lot of innovative tactics, and then they would negotiate with the health systems. So now a scalpel, if you go to this place, costs $10, and it goes to this place, costs $11.50, but the patient can't worry about it because it's, for them, it's still $1, right? And then that just evolved for like 30 years. And now that's why you have this big machine. But there's a lot more in the book, and like payers do a lot of work too. Cool. Any other questions? Oh, yes.
I have
Okay. Mhm.
I have another question. So I was wondering, in ideal world, so what's preventing individual patients to own their own health record information? Is it
Mhm.
because the process of informed consent is very complicated, or is it because the institution wants to behold the ownership of the data for medical purposes? Like, is it more on the legal side, or is it on the what's blocking it from happening?
Yeah, that's a good question. So the question is just like, okay, why don't patients have more say in like how all this data stuff's managed? Because clearly we're all entitled to a record like legally of this data. Is it like political things? Is there other reasons? So it's a combination of most things, but basically like, so okay, I've been co-founder dating for a while. Everyone's like, let's just start a PHR company. Let's start a personal health record. We'll take all this data, we'll democratize it, yada yada. Great idea. No one disagrees. The things that make it hard is a traditional personal health record. If you're just managing your own health records, people don't want to do that, right? It's just like, all right, like if I get sick, knock on wood, I just want my doctor to know. I don't want to think about it. So it's hard to build an engaging consumer app because it's like, why would I want to stare all day at my medical records? The second thing, how could you prove to this health system that you are the trusted party on behalf of this person? Kind of the question of like universal identifiers is like, okay, basically trust-wise, yeah, how can these health systems trust to hand this off to you? So those are hard problems too. There's some interesting ideas in cryptography land that they're thinking about, like differential privacy and yada yada, secret sharing, but that cover this. So basically, it's hard to build the consumer app because everyone wants a thing, but no one wants to think about it. Not really consumer behavior. Hard to get people to share because of the trust issue. And also, like technically, you're asking people to do more work, and if you don't have a good reason, it's just hard to justify that. But there are a lot of PHR companies. There's an open source one called Fast and Health, which is interesting. There's a paid one called Picnic Health, and they're VC funded, and they just like they have an MP like call everywhere you've been, and then they manually curate it on your behalf. Yep. Sweet. Any other questions? Cool. Awesome. All right. Thank you. Feel free to grab more food, and yeah, appreciate it. Thank you. Yeah. Yeah, I did. Yes. No, so I did the OMSCS program. So